nth term of a geometric sequence is determined by the formula t sub n is equal to t sub 1 times r raised to n minus 1, where t sub n is the nth term, t sub 1 is the first term, r is the common ratio, and n is the position of the unknown term.
Now let us determine the nth term of this geometric sequence. We have 2, 8, 32, 128, and so on. And we are going to determine t sub 9, or the 9th term of the geometric sequence. So using the formula t sub n is equal to t sub 1 times r raised to n minus 1, we can determine the 9th term. Let us first identify the needed values to solve for the nth term. So our t sub 1 is 2. Our common ratio is 8 divided by 2 is 4. And then n is equal to 9. It is equal to 9 because the location of the unknown term is 9. Now let us substitute the given value. So we have t sub 9 is equal to 2 times 4 raised to 9 minus 1. Let us simplify by following the order of operation. So we are going to start first with the exponent, 9 minus 1. So t sub 9 is equal to copy 2, then copy also 4. Then 9 minus 1 is 8. Then we have t sub 9 is equal to, now between multiplication and exponent, we are going to get the power first, the 4 when raised to 8. So 2 times 4 raised to 8 is equal to 65,536. Then we are going to multiply 2 and 65,536. We now have 131,072. So the 9th term of this geometric sequence is 131,072. Now let us proceed to the next example. So we are given t sub 1, which is 3. R is equal to negative 2, and then we are going to look for t sub 7. Now, since the unknown term is t sub 7, that means the value of n is equal to 7. Using the formula again for the nth term, we have t sub n is equal to r, t sub 1 times r raised to n minus 1. Substitute the given value. So we have t sub 7, because we are looking for t sub 7, is equal to 3 times negative 2 raised to 7 minus 1. So again, we are going to perform the operations in the exponent. So t sub 7 is equal to 3 times negative 2. 7 minus 1 is 6. Then we are going to get the power of negative 2 when raised to 6. Copy 3. So negative 2 raised to 6 is 64. Now remember, when you raise a negative integer to an even exponent, the power is positive. But when the exponent is an odd number and your base is negative, the power is negative. Now let us go to the last step. We are going to multiply 3 and 64. So 3 times 64 is 192. So the 7th term of this geometric sequence is 192. So in our third example, we are given the general term of the geometric sequence, which is t sub n equals 2 times 3 raised to n minus 1. And we are going to determine the 4th term. So that means our n is equal to 4. Now using the general term, we are going to substitute substitute the value of n. We have t sub 4 is equal to 2 times 3 raised to 4 minus 1. So t sub 4, again, follow the order of operations. Perform first the operations in the exponent. So 4 minus 1 is 3. Then t sub 4 is equal to 2 times 3 raised to 3 is 27. Then multiply 2 times 27 is 54. That means the fourth term or t sub 4 of this sequence is 54.
The given examples used the explicit formula. You can also determine the nth term of a geometric sequence using the recursive formula. That is, to multiply the preceding term by the common ratio to get the next term and repeating the process until you get the unknown term. For example,
to determine the nth term of a geometric sequence using the recursive formula, we just need to multiply the preceding term and the common ratio. Now, for example, we have here 2, 8, 32, 128, and then we are going to determine the ninth term. Let us determine first the common ratio, which is equal to 8 divided by 2 is 4. You can also determine the common ratio by dividing the third term by the second term or fourth term by the third term. Now, since the last given term is the fourth term, let us now identify the fifth term. So the fifth term is equal to t sub 4 times the common ratio. Substitute the given values. We have 128 times 4, and that is 512. Now the next term is the sixth term, which is equal to t sub 5 times the common ratio. Substitute now the values. We have 512 times 4, which is equal to 2048. For the seventh term, we have t sub 6 times the common ratio, and that is equal to 2048 times 4. So we have 8,192. Then for the eighth term, we are going to repeat the process until we get the nth term or the unknown term. Now let us go back to the t sub 8 or the eighth term. So that is equal to t sub 7 times the common ratio. So t sub 7 is equal to 8,192 times 4. So this is equal to 32,768. Now let us go to the unknown term. So t sub 9 is equal to t sub 8 times the common ratio. So we have 32,768 times 4, and that is equal to 131,072. So the ninth term of this geometric sequence is 131,072.
since you already know how to determine the nth term of a geometric sequence, try to determine how much Mia would save at the end of 1 year using the explicit formula. I am quite sure that you used the recursive formula in answering activity number 1. Did you get the same answer? If yes, very good. Let us now go to the total amount Mia would have saved in 1 year. This one involves geometric series. Watch the examples below.